Hey, this is going to be test 3-2 review. This is going to be page 1. So looking at number 1, it says determine if the models below would be an example yes or non-example no of the Pythagorean theorem. Now remember, whenever we have 3 squares and they're joined at their vertices, in order for it to be an example of the Pythagorean theorem, it should form a 90-degree angle. So it should form a right triangle. And all sides should form squares. So let's take a look at our first example. So looking here, I need to identify, do I have a 90-degree angle? I do not have a 90-degree angle anywhere on this triangle, so this tells me no, this is not an example of the Pythagorean theorem because there is no 90-degree angle. So now let's go ahead and take a look at our next example. So this is going to be this model at the bottom. So first I see my 90-degree angle. I point my arrow to C. So yes, it does have a 90-degree angle. Then I need to check, do all sides form squares? So this side here is 1, 2, 3, 4, 5, 6, 7, 8, 9. But however, I see it does not form a 9 by 9 square here. So this cannot be an example of the Pythagorean theorem because there is no or not all sides form squares. Okay. Then let's go ahead and look at the top. So here I see that I do have a 90-degree angle. I point my arrow and it does point to C. Now the other two sides, we'll go ahead and label this side as A and this side as B. Now we're going to go ahead and count the side lengths. And remember, we're putting this into the formula A squared plus B squared equals C squared. So for A, we have 1, 2, 3. A equals 3. So this becomes 3 squared. Plus B, which is 1, 2, 3, 4. So B equals 4. And then I have C, which C is 1, 2, 3, 4, 5. So C equals 5 squared. So now, if you haven't noticed, I've been saying the word squared. 3 squared, 4 squared, 5 squared. Now I need to check, do all of my sides form squares? So looking at A, I have 3 squared. So this is, I need to check, does this create a 3 by 3 square? I see that all sides have 3 units. So this does form a 3 by 3 square. Now I want to find the area of this. So to find the area, I'm going to put 3 squared in my calculator. 3 squared gives me 9. So this A squared, the area of A, is going to be 9 units squared. Then I look at B. So for B, I have 4. And I'm saying 4 squared here. So I should be creating a 4 by 4 square, which I do. Now I want to find the area of this square. So 4 squared equals 16. So here, B squared equals 16 units squared. Then I have 5, so I need to make sure, does this create a 5 by 5 square? I see it does create a 5 by 5 square, so I'm going to go ahead and put 5 squared into my calculator, and I get 25. So C squared equals 25 units squared. Now, if you remember when we went over examples and non-examples of the Pythagorean theorem, I said that whenever you add together the two smaller sides of whenever you add the area of your two smaller sides, it should add up and equal the area of your largest side. So the area here is 16 and 9, and so 9 plus 16, does it equal 5 squared, which is 25? So let's just go ahead and check that. 9 plus 16 does equal 25. So here we have 25 equals 25. So yes, this would be an example of the Pythagorean theorem. Okay, next let's go ahead and look at our next example. So here I have 3 squares. They are formed, or they are joined at their vertices to form a right triangle. So what I want to check is, do these 3 side lengths, whenever they form a right triangle, or do they form a right triangle? So here I want to find the area first. So I'm going to take 10 squared. 10 squared equals 100, so this is 100 inches squared. Then I'm going to take 24 squared. 24 squared equals 576 inches squared. Then I have 26. So 26 squared equals 676. So this is 676 inches squared. So now, again, like I mentioned earlier, we want to add the area of our two smaller sides. So we're going to add 100 and 576. And we want to check, does it equal 676? So 576 plus 100 equals 676. So yes, this would be an example of the Pythagorean theorem. So that's going to be number 1. Let's go ahead and look at number 2 now. So number 2, it says the coordinates of the vertices of the triangle are shown. They give us the coordinates for E, F, and G. And we want to know what is the length of the segment EG in units. So we are looking for the length of between these 2 points. Now, you cannot just go and count this. What you have to do is, again, it's formed a right triangle, so you can use the Pythagorean theorem to find the distance between E and G. So here I have identified my 90-degree angle, and I'm drawing my arrow to C. I'm going to go ahead and label this side as A and this side as B. So now what we want to do is count our side lengths. So here this is 1, 2, 3. So here B equals 3. And for A, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So here A equals 9. So to find the length of C, we're going to use the Pythagorean theorem, which again, the formula for that is A squared plus B squared equals C squared. We're going to go ahead and substitute our information in. So for A, we have 9. So this becomes 9 squared. Plus B, we have 3 squared. And this equals C squared. So now we're going to simplify our exponents. So 9 squared equals 81. Plus 3 squared equals 9. And this equals C squared. Again, we need to simplify this. 81 plus 9 is going to equal 90. And this equals C squared. Now your last step is to take the square root on both sides. So the square root of 90 is going to be 9.48. We're going to go ahead and round that to the tenths place. So here C is 9.5 units. And that is number 2. Let's go ahead and take a look at number 3. So number 3 says an engineer joined 3 squares at their vertices to create the figure shown below. The engineer will use small congruent square tiles to cover each square without any gaps or overlaps. Based on this information, which statement is true? So again, remember when we went over examples and non-examples of the Pythagorean theorem, when we add together the 2 smaller sides of our right triangle, it should add up and equal the area of our largest side. So keeping that in mind, we should have the area of square A and B. It should cover the area of square C. So let's go ahead and look at our answer choices. So for A, it says the number of tiles needed to cover square B, which is this tile or this square here, is the same as the number of tiles needed to cover square A and square C. So what this is saying is that when we add together the areas of square A and C, it should equal square B, which is not true. In order to find the area of square B, what we would actually do is take the area of square C and subtract the area of square A to get square B. So A is not your answer. Let's go ahead and look at B. So B says the number of tiles needed to cover square A, which is this square here, is the same as the number of tiles needed to cover square B and square C. So again, that's saying about the same thing A says. So it's saying that whenever you add together square B and C, it should add up and equal square A, which is not true. Again, we would take square C and subtract the area of square B to get square A. So B is also not true. Lastly, looking at C, the number of tiles needed to cover square C is the same as the number of tiles needed to cover square A and B. So again, what that's saying is when we add together square A and B, the area of those 2 sides, it would equal the area needed to cover square C, which is correct. So C is our answer for number 3. Okay, next we're going to go ahead and look at number 4. So for number 4, it says, write yes or no to state whether the given side lengths would form a right triangle. So you've been given 3 sides, and you're going to be putting this into the formula, A squared plus B squared equals C squared. And first thing you should do is identify your hypotenuse. Now, remember your hypotenuse is C, and if you remember from the very first day of notes, that your C is always the longest side of your triangle. So looking here at our first three numbers, we have 28, 53, and 45. The largest number is 53, so 53 would be C, and then I'm going to go ahead and label 28 as A and 45 as B. So then you would go ahead and plug this into this formula. So for A, we have 28 squared plus B is 45 squared. And this equals C, which is 53 squared. So if you did have your TI Inspire, you would be able to plug this in, and it would either return true or false for you. But since I don't have my TI Inspire, and since you most likely don't have it at home if you're watching this video, we're going to go ahead and solve this by hand. So 28 squared is 784. So I'm going to put 784 plus 45 squared is 2025. And then 53 squared is 2,809. So now I'm going to simplify. I'm going to add 784 plus 2,025. And that equals 2,809. So here we get both sides equal each other. So yes, this would form a right triangle. Next, looking at our next problem, we have the numbers 50, 48, and 14. So again, we need to identify our hypotenuse, which again is the longest side. So here, this would actually be 50. So 50 is C, I'm going to label 48 as B, and 14 as A. So again, putting that into this formula, A squared plus B squared equals C squared. We have 14 squared plus B, which is 48 squared, and this equals C, which is 50 squared. So we're going to simplify our exponents. So 14 squared equals 196 plus 48 squared equals 2,304, and this should equal 50 squared, and 50 squared equals 2,500. So again, we add together our two smaller sides, so 196 plus 2304, we get also equals 2,500. So here we have 2,500 equals 2,500. So yes, this is an example of the Pythagorean theorem. Okay, next we're going to look at our next problem. We have 4.5, 6, and 7.5. So again, start off by identifying your longest side, which would be your hypotenuse. In this case, it would be 7. So I'm going to label 6 as B and 4.5 as A. So then let's go ahead and plug this into our formula. So for A, we have 4.5 squared plus B, which is 6 squared, and this equals C, which is 7.5 squared. So 4.5 squared equals 20.25. I'm going to add 6 squared, which is 36, and this equals 7.5 squared. 7.5 squared equals 56.25. So now I'm going to add together those two sides, 20.25 plus 36 equals 56.25. So here we have 56.25 equals 56.25. So since both sides equal each other, yes, this would be an example of the Pythagorean theorem. Okay, so last statement, we have 25 centimeters, 16 centimeters, and 12 centimeters. So again, start off by identifying your longest side. Your longest side here would be 25. I'm going to go ahead and label 16 as B and 12 as A. So again, we start off by substituting this information into our problem. So for A, we have 12 squared plus B is 16 squared, and this equals C, which is 25 squared. So then we simplify. We have 12 squared equals 144 plus 16 squared equals 256. And this should equal 25 squared, which is 625. So then again, let's simplify. 144 plus 256. And this equals 400. So here we have 400 equals 400. We have 400 equals 625. However, 400 does not equal 425, so no, that last one would not be an example of the Pythagorean theorem. And that completes page 1.